Well, the timing says I start or I end at noon, and it's noon. I've been in the satellite making business for 30 plus years, and I feel right at home. It's all good. Uh, I have a bunch of slides. Hopefully, you guys can get access to them because there's really about four that are super important, and I'll go through those, and then we can talk about the other ones later. So, who are we? You know the folks at the School of Earth and Space Exploration at ASU, and I should say thank you, U of A, for inviting us down. It means a lot, and we're happy. All ships rise with the tide, and when you guys do better, we do better, and when we do better, you do better. So we're really happy to be here. You know CC, and they have the instruments, and we work with CC all the time. We have other departments and professors doing engineering work and instrument work. But what we are is we're a pan university, so we work with all the departments. We're in Knowledge Enterprise, which isn't in any of the colleges, it's with all the colleges. And we run, the Interplanetary Lab is a core facility. So we not only work with the faculty and staff and students at ASU, but we can work with commercial partners, we can work with other universities, and it can be on a fee-for-hire kind of arrangement. What we have is all of the capital equipment. So we have full electronic development. We have light CNC machines and 3D printers and things like that to do prototyping and flight hardware. We have environmental test chambers and anechoic chambers and all those specialty test equipment. But the thing that makes it different, and I know that you've struggled with this, and everybody struggles with this, you have the peaks and valleys of hiring and then not having the work, and then having to hire and having it be noon when you're supposed to be done already and not having your staff of engineers ready. What we're doing is we're training the engineers and getting the pipeline ready. Not all of our staff, I'm not a student, but our staff is highly student and highly undergrad and grad level, but highly undergrad students. So we'll have, we'll be training. So the missions that we're taking on are CubeSat missions, which perhaps aren't cutting edge science, but they are teaching this next generation. We have, like I said, we work with staff from around our university and other universities, capital equipment. And then the little catchphrase is, we're a space maker, makerspace. And if you're familiar with the makerspace, it's where you just have the tools there and anybody can come in. We're at a higher level than hacking, but we're not at that, JWST level of everything has been checked 100 times. Really quickly, so I'm the chief engineer. We have Danny Jacobs is the director. We're under the Interplanetary Initiative whose director is Lindy Elkins-Tanton. Our staff is mostly those 6 students that are under the student staff, and they make sure the other students don't get hurt. They also do most of the prime, what would you say, engineering on our missions. We've developed a technique where we can take in volunteers who are freshmen and train them up. So they go freshmen and they might get a micro grant where they can work on a project of their own for $400 or $500. And then when they kind of show that they have the talent, the skill, the initiative, the passion, then they'll go up into an area where we pay them, but they're not the, we call them lifeguards as the top level staff, and they're working 20 hours a week at a typical rate that undergraduates would work. But we just, it's a reverse waterfall. We're working them up, getting their skill up there, and as they do better, we pay them a little more. Our facility, and I'm gonna go through these charts pretty quick, so I'm gonna just stand over here. It's 6,000 square feet plus. I put the plus in there because there was an extra room. We're in an old gym. It's Sun Devil Hall. We We kept the lockers. It's enough of a gym that when you walk in, although it's all brand new, drywall and everything's nice, the carpet's fresh. If you go in the back room, there's still shower heads on the wall because it was a shower. And so what do we do in there? We put things like our lunar sandbox and things that are dirty. We keep them in those separate areas, and that's in the plus area. We have a ground station. Recently, and we have a history of launching hardware. Our most recent launch was called LightCube. It's a 1U CubeSat. It was a CSI mission. It's up there right now, and we're talking to it on our UHF ground station. It's on the top of one of the buildings on campus. And again, I want to emphasize this was all student, all the work was done by students. We have engineering professionals who also come in and mentor on Wednesday nights. Full electronics lab, won't go through it for the sake of time. We have tabletop CNC, laser cutter, mechanical tools, things like that. Testing lab, this is super key. We have a vibe table, and that's one of those specialty equipments that just is unacceptable, unobtainable by many of the small student kind of run projects, where when they have access to it, they can learn how to use it, they can use it, but if they have to go outside to a vendor, it's going to be thousands of dollars that they just don't have. Anechoic chamber, here's our lunar sandbox. One of our outreach projects is a rover that can be teleoperated from a high school or from another part on campus, another lab on campus. And it's part of our development of how do you train future scientists to operate remotely a complicated scientific instrument. So what we do is we make the students develop sensors to an ICD that then is put onto the rover, and they go through all the steps, it's just much simplified, and then they have to operate it, teleoperate it. And they learn how the decisions they made early on in the semester affect them later. And then this isn't all our projects. LightCube is up. Dora and Sparks are two 6U CubeSats that are in development. We'll be doing various levels of either development or just environmental testing. Romer was a study that we did for the Space Force for an agile spacecraft with manipulated arms. And then the last one, the Charlotte, and a lot of these aren't acronyms, or if they are acronyms, they're just straight up the words, they weren't backronyms. Charlotte's a walking robot for the moon. That one, we just did the test. That's what we developed the lunar sandbox for. And we're able to do specialty tests like on the tether to find out how much rubbing it can do across rocks. And it turns out it can't. It's about 10 minutes of rubbing and it breaks. LightCube, we sent the students out to NASA to launch. I'm just going to go through these quickly. Dora's a 3U, sorry about that, not the 6U. Sparks we're doing, we do have some content with U of A. This is one of the, some of the science is being done here. There's our sandbox in the showers. What you can't quite see is up in the upper right would be the shower head. And then, our coconut, which is through one of the student engineering student clubs, Sun Devil Satellite Lab. It's a store and forward. It was just recently awarded CSLI launch. It's in conjunction with the lab, and it will be again at UHF frequencies. Oh, that's right. Coconut. It doesn't mean anything. It's just called coconut. It's the size of a coconut. So if you have any questions, that's my presentation. He asked if we have a class to funnel the students. We have a couple classes, but that's not our only funnel. So yes, we have 2 different classes in 2 different colleges, strangely, but they're very, well, because the engineering does some things, and then the science, School of Earth and Space Exploration, is under liberal arts, and so they do straight science, and that's why there's 2 different classes. We advertise a lot. There's a lot of competition at ASU to get the good students into your club or lab, and so sometimes we're in competition with other labs to get the good students. It's a good place to be. Yeah. The questions, if we just focus on CubeSats, primarily, yes, all our equipment is designed to do up to 12U CubeSats. So that's, borderline, is that it's still a CubeSat? But we also do testing for other things like the walking robots and things like that. But yeah, fundamentally, it's a CubeSat lab. Thank you all.